In this video presentation, we will design and build a simple circuit to illuminate an LED. So what parts do we need for this project? Well, to start off with, we need a breadboard on which we will build the circuit. We also need a 9-volt battery to power the circuit and a means of connecting the battery to the breadboard. We can either do this using a battery clip or a battery box, whichever you prefer. We also need one 5mm LED. Popular colours are red, green, orange, yellow. You can choose whichever colour you want. There are plenty of other colours available as well as the ones I've shown here. And finally, we need a resistor which will be used to protect the LED. But what size should it be? To calculate the size of the resistor required to adequately protect the LED, we can use Ohm's Law. So in order to calculate the resistance, we need to know what the voltage is and what the current is. So as stated here, the voltage is the battery voltage, which is 9 volts, minus the voltage drop across the LED. So the forward voltage drop is the voltage that is lost in the LED when it is operated at a certain current. If we assume a voltage drop of about 2 volts, which is fairly typical for an LED, then this gives us a voltage value of 7 volts, which is what we'll use in Ohm's Law. And we also need to know what the current is. Most LEDs require somewhere between 16 mA and 20 mA in order to shine brightly, but without causing any damage to the LED. So 20 mA is what we will use in Ohm's Law. If we now put the voltage and the current into the equation, we can calculate the resistance. To be on the safe side, we'll go for a slightly bigger resistor, say 470 ohms. The resistance value of a resistor can be worked out by looking at the bands on the resistor. For a 470 ohm resistor, the bands are yellow, which represents 4, violet, which represents 7. You can then put these two numbers together, which gives you 47, and then multiply them by 10, which is indicated by the brown band. The gold band at the end means that the actual resistance value will be somewhere in between plus or minus 5%. Now that we know which size resistor we're going to use, we can design and build the circuit. And firstly, here we have the circuit shown using nice little real-life images to make it easy to see where the components go and how they fit together. It doesn't matter which way around the resistor goes in the circuit, it is a non-polarized component. But the LED, on the other hand, has to be inserted with the long terminal, the anode, on the positive side of the circuit. Circuits are quite often shown using schematic symbols to represent the components, as shown here. And this is what the circuit looks like on a breadboard. Again, we need to make sure that the LED is inserted the correct way round. Here I've labelled the cathode, which is the short terminal. And here are a few photographs that show the actual circuit being built. So we start off with an empty breadboard, and then the first thing we can do is to add the resistor. Then we can add the LED. Here again I've labelled the anode this time, which is the long terminal, and also the cathode. And finally we can complete the circuit by adding the battery, so connecting up the positive terminal and the negative terminal. And it works. Fantastic. Thank you very much for watching.